Hello and welcome guys. So in this video I'm going to make a machine learning model which will do a car prediction. So I'm using the dataset from Kaggle. So let's go to this link which I will provide in description. So this is a car dataset and 100,000 UK used car dataset, and so here this is our dataset. So you can download this dataset from here and just see the dataset and our task here. Let's go to task. So our task here is to make a tool to predict a car value. So we have to predict the price of this car. Okay, so let's download this dataset. So I have downloaded this dataset. So after downloading you will see this type of you will see the CSV file like this. So this is a very long dataset you can use to predict you can use to make a machine learning model, but like if I open this bmw.csv, so this is the dataset of bmw.csv model, and here price, and this is transmission, mileage, fuel type. This is the features of this dataset. Okay, so like this I'm in this project I'm using audi.csv dataset, this dataset audi.csv dataset. So I'm using here audi.csv dataset. I'm going to predict the price of Audi. Okay, you can use other also with the same logic. You have to use the same logic which I am going to use in this video. So you can follow these steps and learn from this video, and as a homework you can try on BMW and C-Class, Focus, Ford, Hyundai, Mercedes, Skoda, all this you can try on yourself. So this is our dataset. So before going to code and make a machine learning model, you have to analyze your dataset, and you have to see and you have to visualize everything in the dataset, what you have to do with the help of and which feature you have to use. All this stuff you have to visualize. Then after that you go for code. Okay, before building any project, before building any machine learning project especially related to this data set, especially dealing with data set, you have to visualize this data set, and you have to find what you have to do, how you have to proceed by using these data set. Okay, so you have to analyze this data set and understand what you have to do. So as you see, this is a model number is given in the data set, approx this is a very long data set, approx 10,000, I think. Yeah, more than 10,000. And this is year given, this is price given, and this is transmission, mileage, and these all are different types, different feature of the Audi. Okay, so these all are the features of the car. This is model, and in which year it is launched, and what is that price, and what is transmission, and what is its mileage, fuel type, whether it uses petrol or diesel, and what tax you have to pay, what is MPG, and what is engine size. All this stuff is given, and you have to predict the price. This is the feature you have to predict. So you have to make a model using all these features, so that it use this feature and it finds some relation using these features, and then it predict this price. Okay, so in machine learning we can say that it is our dependent variable which depend on all these features: model, year, transmission, mileage, fuel type, tax, MPG, engine size. So these all are our independent variable. Using these feature we have to predict this dependent variable. Okay, So this become our y, and all this feature will become x. Okay, so we have to do some we have to equate by doing some relation we have to find, so that using all these feature, our model is going to predict this dependent variable price. Okay, so we have to find some relation, and these all relation are going take place in machine learning. Using machine learning algorithm are going to do everything. Python, as you all know that there is scikit-learn library which is going to do everything, but we have to understand the theory behind it. We have to understand the internal structure, how these all this stuff are happening. So you have to also visualize all this, and you have to understand all this stuff, because blindly you are coding and uh, making your model is sufficient in machine learning. You have to understand how all this process is happening. Python community and everyone is provided us algorithm. Every algorithm is made, we can blindly do and make our model, but we have to know, we have to understand how it's all happening. So that's all. So our first step is done. First step, what is first step in machine learning? Before making any model, first step is to analyze your data set. First step is to look the data set and visualize your data set, and make sure to extract the important information. So here, as we see that model here, everything is important. So there is no any values which we have to discard, and every feature is important, because every feature is going to give its contribution to predict to make a price. Okay, so price depend on all these features, so we have to consider every feature of this data set. Okay, so our first step is done. So we know what we have to predict, what is going to be y and what is going to be x. So first step is done. Now let's go to code. Okay, so now let's get started. And first of all, I'm going to comment out here, this is importing libraries. Okay, so here I'm going to use first of all Numpy. Numpy is very important. Numpy as NP, and second one is import Pandas SP. I think my recommendations of why, because Google Colab is not connected. So let's upload the dataset, because next step I have to read the dataset. So let's upload it. So in Google Colab, to upload your dataset, and one more thing, you can use Jupyter Notebook also. But if you're going to use Jupyter Notebook, then you have to install all these libraries, NumPy, Pandas, everything in your PC. On here, you can use also Anaconda. Okay, if you are using idle or any other text editor, then in command prompt you have to pip install every library like this. Pip install numpy pandas and scikit-learn. All these library you have to install. So I'm not going to install any library, so I'm going to use this Google Colab. The beauty of Google Colab is fast, and I think fast coding we can do in Google Colab. Okay, that's why Google Colab I'm using. Google Colab is fast and everything is clean, so I'm going to use Google Colab, and there is no need to install any library. You can directly use any library. There is no any installation you have to do here, because it's Google Colab have everything pre-installed. Okay, so here I am imported NumPy pandas, and next library I think scikit-learn we will import later. Okay, so our library is imported. So next step is to import our dataset. Okay, importing dataset. Okay, so next step is to import dataset. So let's define one variable. Dataset is equal to pd dot read underscore read underscore csv is the function of pandas to read the csv file. Okay, so read underscore csv audi dot csv is this is the location of our dataset. Okay, this is the file. So as our program is in the same folder, in the same directory where our csv, so that's why I'm using directly the name with its extension. And if your dataset is somewhere else, then you can use, as you are using Google Collaborative, if you are using Jupyter Notebook or any other, then you have to give a proper location of your dataset. If your dataset reside in the same directory where your IPYNB file is, then you can directly give a name with its extension. But if you are your dataset is somewhere else and you are using your IPYNB file Jupyter Notebook, then you have to give its location. Okay, so this is pandas dot read csv. This is a read csv function of pandas. This is pd pandas. So read csv function consists of first argument as the dataset location, and second argument and it also consists of many arguments like delimiter and every other stuff. But here as you see that our dataset has a label, everything is here. If your dataset is not labeled dataset, then you have to use something else, some more feature of pandas. But this is a regression, this is supervised learning problem, supervised machine learning problem, so that's why there is no need to use further any argument of this pandas.read csv function. Okay, and one more thing I want to explain here, that this is price, so we have to predict the price. Okay, one more thing you have to understand here, that we have to predict here price. Okay, we are not going to do any yes or no or any discrete prediction. Okay, in the form 0 or 1 or 1 2, like good or bad, like this we are not going to predict here. We are going to predict a continuous value. We are going to predict a value. So this is a regression problem. Okay, this is the difference between classification and regression. Classification means you have to predict something, both we have to predict. Okay, prediction are done in both. Okay, so in classification you have to predict discrete values like 0 1 2, like this, good bad, something like that. But in classification you have to predict discrete value. Okay, like good bad 0 1, like this. But in regression you have to predict a continuous value. Continuous value means a value like 11,000 1600 16,000, like this you have to predict. Values are different, there is no fixed value. Okay, so this is the difference between classification and regression. Okay, so this is, as we see, it's clear here that it's a regression problem. Okay, so we have to apply a regression machine learning algorithm, all machine learning algorithm related to regression. Okay, so you have to understand that this using, by visualizing the data setting, you have to see what we have to predict. If there is no price here, if there is color, let's say here is color, we have to predict color. So color are discrete, color can be red, color can be blue, that is color is fixed. There is no any extra color like any other color is fixed. But here price is going to be continuous. Okay, price is not going to be like here 12,500 and next is 16,500 and next again 12,500. price is going to be different every time. It's different. Okay, it's not a discrete value. Discrete means something which is fixed. Okay, it's not a discrete value, it's a continuous value. If we are going to plot a graph of this price, then we get a continuous curve. Okay, we are not going to get a discrete curve which is going from 0 to 1 like this. Okay, so you have to understand all the theory behind this, that which is which algorithm, which machine learning algorithm we have to use. Okay, by visualizing the data set. Okay, so let's get here. So our data set variable is defined. So this pd.read csv function will read all the data. This is our data set. So all this data set is stored in, all this data set is stored in this data set variable. Okay, so next is we have to define our x and y, that is independent and dependent variable. Okay, so to make x, you have to use dataset dot one more function of pandas, that is ilog. Ilog will contain first argument as colon and second argument. Well, first of all, I want to explain what is the use of this ilog. Okay, so what is x and what is y in our data set? So we have to see here. So this is our x: model, year, transmission, mileage, fuel type, tax, mpg, engine size. These all are x. These all are independent variable, which is going to by using all these variable, we are going to make a independent variable. By using all these features, we are going to get a price. Okay, so this price depends on this model, year, all this stuff. Okay, all these features, all this feature. Okay, so our x is this, 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 this. Okay, so in Python, index start from 0. Okay, so what is this ilog function? Ilog function basically divide or data set in the form, this is ilog function will accept this first as a row and second as a column. Okay, first argument as row and second argument as column. So in Python, if you want to give everything, so this is a part of string slicing. So to so here our x variable is all this column, this one, this one, this one, this one, this one, all these columns, and all rows, every rows we have to consider. Okay, so here to consider every row, we have to use this colon. Colon is going to give a Python as an instruction that Python consider every rows of this data set. Okay, and in column you have to consider here 0th index, first index, not second, because second is y. 0, first, third, fourth, fifth, sixth, seventh, eighth, you have to consider. Okay, so 0th index, first index, not second, third, fourth, fifth, sixth, seventh, I think 0, 1, 2, 3, 4, 5, 6, 7, 8, you have to consider here 8. So this is our complete row and this is our column, which are going to be x. Okay, and make sure here this is in the form of list. Okay, so it's going to be two-dimensional list. These all are part of string slicing. You have to understand this before going to make a machine learning model. You have a basic idea of Python. Okay, so this is a part of string slicing. String slicing will as you all know that if you know Python, string slicing makes a new list. Okay, this is a This is the importance, this is the main thing, main fundamental about string slicing, that string slicing always generate a new list. Okay, so our x is done. Okay, and one more thing you have to give here, to extract its values you have to give dot values. This is going to extract the values of these features. Okay, that's why I have provided here dot values. And now we have to take our y. So y is what? Y is all rows, and second argument is for column. So we have to provide index of column. So what is index? 0, 1, 2. 2 is the index of column. So here I'm going to give this 2. Okay, dot values. Dot values will take all its values of that column. Okay, so this is our x and this is our y is defined. Okay, so let's run this code. And here print x, print y. Let's print x and print y and see. So here as you see that this is in the form of two-dimensional list. Why? Because one is due to this and other is due to slicing. So we get here two-dimensional list, and here also we get two-dimensional list. Okay, so this is our two-dimensional list, x and y in the form of 2D list. So make sure that before doing any data pre-processing you have two-dimensional list, because sometimes user many error we are facing by just using this. If you are going to use like this, then you will get here one-dimensional list like this. Okay, so try to use here this type, so you will get two-dimensional list. Okay, so here as you see you get two-dimensional list. Later I will tell you how to convert one-dimensional and two-dimensional, because I am going to use this step I am going to use in this code. Okay, so our x and y is done. Now we have to do some encoding. Why encoding? Because machine learning algorithm always accept numerical value. This A1, this manual automatic machine learning model will not, machine learning algorithm is not going to understand this, because everything is mathematical. Machine learning algorithm are using algebra and all, going to make equation and going to find out relationship, correlation in between. So everything is mathematical in machine learning algorithm. Okay, so that's why we have to provide a mathematical value, not these type of values A1 and this manual. This is going to give us error. Machine learning algorithm is not going to understand all these values. Okay, so in our feature we have to convert all this type of values and this type of petrol, diesel, this type of value in numerical form. Okay, to convert it into numerical form we have to use encoding. So there are many types of encoding you can use, like label encoding and one hot encoding. It depends on your data set which encoding you can use. Okay, so here as you see that this dataset model feature consists of A1, A6, A4, these all. Okay, so there is a very large variety of this feature. This feature consists of very large variety: A1, A2, A3, A4, A5, A6, very large varieties, Q3, these all. So if variety is large, okay, so I am going to give you a one trick to use the encoding. Sometimes many students are confused in which encoding we have to use, which encoding we have to consider. So here, if your variety is large, then I will recommend you to use level encoding. Okay, and if your variety is less, then you can use one hot encoding. Okay, suppose here it's manual and automatic, so here only two variety as we see here. So if I am going to use here one hot encoding, then one hot encoding is going to produce a separate column for manual and separate column for automatic. And if manual, if feature contain manual, then it's going to give here one, and if feature contain automatic, then feature is going to give here one. Okay, and if it's not manual, then feature is going to, then that column will be 0. Okay, so like this one hot encoding is used. Okay, so if your feature is very large, then one hot encoding will generate many columns, so your and so there is very large computation, and it's just increases the complexity of your model, and it slow down your model and training process. It also affect your training process of your model. So try to use one hot encoding only when your features variety is less, that is of 2-3 varieties. Like here as you see, it's automatic, manual and semi-automatic. So here there is 3 variety. I think it's here only 3 variety. Okay, so you can use here also, and you can also use in petrol, diesel, as you see here also only 2 variety. So one hot encoding you can use either in here or here, it's your choice. Okay, so I think you understand the logic when to use level encoding, when to use one hot encoding. Okay, so next I'm going to give a comment data pre-processing, because now data pre-processing phase is going to start. So in data pre-processing phase, first step is let's comment out here with level encoding. Level encoding. Okay, let's give here 2 hash because values. Okay, so first of all I'm going to give a level encoding. So let's import this scikit-learn from scikit-learn pre-processing. We have to import level encoder. Okay, so let's create one instance. le1 is equal to level encoder. Okay, so our instance is created. So where we have to apply level encoding. Okay, we have. So first of all I am going to apply level encoding in model feature. So in x, this is our first 0th index. Okay, so this is first element of x, so it's a on 0th index. Okay, so let's give here x. I'm going to give here x for all rows, because I'm going to apply level encoding in every rows. Okay, so column for every rows, and 0 for 0th column of x. Okay, 0th column of x. Okay, so here give le1 dot fit underscore transform. Okay, so here provide your x. Comma 0. Okay, so x is going to be modified. Okay, and second, where we have to apply level encoding, level encoder. So we have to again define one level encoder, because this le1 is going to work only on this feature. Okay, so to make so to encode other feature, we have to separately define one more level encoding, one more instance to apply on that feature only. Okay, so now select all rows and which feature we have to consider here. So I am going to apply one hot encoding on this feature. So let's apply level encoding on this feature. Okay, I will show you how to apply one hot encoding. So I am going to apply one hot encoding on this feature, but I am going to apply level encoding on this feature. Okay, so to apply level encoding, you have to count index of this fuel type. Okay, so as you know that 0 1 2 3 4 5, this is fifth index of data set. Okay, this is one confusion I want to sort out here. Sometimes many students consider here as fifth, as fifth column, but you have to understand that this data set variable contains that fifth index. Okay, so this is fifth index for data set variable. Okay, but our x is changed. Our x is started from here, here, and here. Our x not consist of this. Okay, so our x is from this is zeroth index of x, this is first index of x, and this is second index of x, this is third, and this is fourth index of x. Okay, not 5. You have to take care of this. Okay, so here our index is 4, not 5. Okay, so let's give here le2 same step, fit underscore transform, and here take all rows, and which column we have to consider? Fourth index of x. Okay, fourth index of x. So I think it's done. So let's run this cell, and before printing x, I am going to apply level one hot encoding also. So let's apply one hot encoding. So to apply one hot encoding, you have to import from sklearn dot preprocessing again. Preprocessing, import one hot encoder. One hot encoder. This is okay. From sklearn dot preprocessing, you have to import one hot encoder. Okay, and next what you have to do to apply one hot encoding, you have to import one more thing. So from sklearn dot compose, you have to import column transformer. Okay, so from sklearn dot you have to import this column from sklearn dot preprocessing, you have to import one hot encoder, and from sklearn dot compose class, you have to import this class column transformer. Okay, and now let's define one variable ct column transformer. You have to give here column transformer. Okay, and pass here one argument as transformers. Okay, transformer is equal to, in the form of list, you have to give list form, and in list form you have to provide tuple, and tuple consists of first argument as first element, not argument, as this encoder. Okay, this is the syntax of one hot encoding. Okay, and second as one hot encoder, this one. Okay, with this function, and third one is index you have to pass, on which you have to apply one hot encoding. Okay, so here I am going to apply 0 1 and 2 on second index. I am going to apply. Okay, second index of x I am going to apply. So here gives 2. Okay, so this is all about one hot encoding. So transformer is equal to first element as transform in list form, you have to give in tuple, and in tuple form you have to give in first as encoder, second as one hot encoder, second third one as index of on which you have to apply. Okay, so this is all about this, but one more argument you have to give after this transformer. Okay, after this transformer is over here. Okay, and one more last argument you have to give, which is remainder is equal to pass through. Okay, remainder is equal to pass through. What, why we are giving this argument, I will tell you from here. So at the time of encoding, one hot encoder is going to encode all this value. Okay, so if I am not going to give this remainder is equal to pass through, then it will only encode new value. Okay, so first time manual is encoded, automatic is encoded, and it will not again encode manual. Okay, it will not again encode manual, it only search for new value. So here semi-automatic is only encoded, and all these value manual, automatic, rest manual, automatic will not be encoded. Okay, so you have to pass this argument remainder is equal to pass through. So it will tell one hot encoder that hey, one hot encoder, which value you have encoded already, put that value in repeating value, where you get the same part, put that one also there. Okay, so suppose manual is encoded, automatic is encoded. Okay, suppose manual is encoded, so further manual, if anywhere we get further manual, then that value of manual is going to be placed on other manual also. Okay, so for same value, to make one hot encoder, that hey, one hot encoder apply uh, which you have already encoded, so apply same on that also. Okay, so that's why we have to pass here remainder is equal to pass through, so that one hot encoder can encode repeating values also. Okay, because one hot encoder always search for new values, because it's going to encode only new values. So for old value which it has already encoded, so we have to pass this function, so that one hot encoder is also going to encode that values which we have already encoded. Okay, so that's why we pass here remainder is equal to pass through. Okay, so our ct variable is defined. Okay, let's apply this on x. This is one hot encoding, so ct, we have to apply this ct on x. Okay, so ct dot fit underscore transform we have to do, and put it x as a argument, and apply this on x. So x is overwritten by this one hot encoding. Okay, now let's print x and see the magic. Print x. So before printing, let's run this cell. This is one hot encoding, and this is, so here as you see, every value we are getting in numerical form. What is this? This is our these three columns are of manual, automatic, and semi-automatic. One more thing I want to tell you here, that one hot encoding will encode, as I previously told you, that one hot encoding is going to convert a separate column for this. Okay, separate column for manual, automatic, and semi-automatic. Okay, so one hot encoding is going to convert a separate column, but one more thing, one hot encoding will convert a separate column and place that column at the first index. Okay, so these three columns are of manual, automatic, and semi-automatic. Okay, so here first value is manual. Okay, so I think this one is for manual, because here manual is 1 and semi-automatic and automatic is 0, and this one is for automatic. So this is for automatic, this is for manual, and this is for semi-automatic. So as you see here, first value is manual, so it is 1.0. Okay, manual is 1, and second value is automatic, so second one is 1.0. First column is 1.0. Okay, so let's see here, first one is manual, so this second column is for manual, so it's 1. Okay, and second one is here automatic, so this first column is going to be 1 and everything else is 0. And third one is again manual, here third one is again manual, so here again second column is going to be 1 and everything else is 0. Okay, so I think you understand what is one hot encoding. Okay, so one hot encoding is done. So we are successfully converted our data in numerical form. Okay, so everything we got in numerical form. Now what we have to do, we have to perform feature scaling. So why we use feature scaling? First question is why we use feature scaling. So I will tell you why we are using feature scaling. We are using feature scaling because feature scaling speed up the training process. Okay, what is going to be done in training process? The question is what is going to be done in training process. So in training process, let's take dataset. Okay, so training process, this y is placed separate, and these all features are separate placed at one side. Okay, and using some coefficient, we are equating y with features x, and we are going to find some relation, and we are going to plot some graph, and we are going to in training it's going to plot some graph, and it's finding some relation that on what factor, what is the value of coefficient which we have to take, so that all these feature depends on this value. Okay, so these all are done in training process. So if you are going to use values like this, somewhere you are using 1 0 and somewhere you are using 150, these values you are using, somewhere you are using approx 30,000 value, 30,000, and somewhere you are using only 1 2 3 4 like this value, then there is lot of variation. Okay, and lot of computation time it takes, so our models is not efficient, and training is also takes very time. Okay, so to avoid all these problems, we are going to use feature scaling. What feature scaling will do, feature scaling will feature scaling will convert every values in a limited, in a definite reason. uh, Here feature scaling will convert everything in between -3 to +3. Okay, so these 15,000 values converted in something in decimal 1.2 or 2.3, and every other values are feature scaled and converted. That's why we are going to use here feature scaling, so that everything is converted in -3 to +3, and our model, and at the time of plotting our graph, we can easily recognize and find out the relation, because if there is some value in 30,000, some value is 1, some value is 2, then at the time of plotting graph and finding relation is very difficult. That's why we are going to use here feature scaling to optimize the training process. Okay, so to feature scale, from in Python you have to use again sklearn or pre-processing. These all are pre-processing step. So you have to import standard scaler. Previously I told you guys that blindly, if you know how, what is when we have to apply. So if sometimes some guys don't know the theory behind machine learning, so they blindly import libraries. And second step, as you all know that in every machine learning model, in supervised learning model, every time you have to import library and then data set, then you have to print x and y, then perform data pre-processing, and you are going to do feature scaling and then training set and test set, converting in training set, test set, then training the result. But these all are going to be happen with algorithm. Okay, these all are sklearn libraries predefined, and it's going to do everything. But you have to know, how all this stuff is happening. Okay, that's why so that you get a complete and deep knowledge how it's happening, and you will do everything. And sometimes when you stuck in any place, then you will definitely find out the error. Okay, that's why you have to know everything, how it's happening and how to do it. Okay, so you have to take care of this. So our standard scalar is imported, so let's define one object for that. So let's give a standard scalar. So our object is defined as C, and apply this on X. Okay, fit underscore transform. Okay, so it's applied on X. Something is wrong. Oh, here S is missing. Oh, here X is also missing. Okay, so feature scaling is done. Let's print X to see the values of X. So here, as you see here, we get something like this, 150, 55.4, and here you see, here we get the values like this. Everything is converted in a definite range of -3 to +3. Okay, everything is converted in a fixed range, so that we can apply very easily, we can train our model. Okay, so it's done. And now next step is to split the data set. Splitting data set into training and test set. Okay, so before going to code, I want to tell you why we are using this step, why we are going to use this. Because we need some data for training, and some data also we don't have any extra data. So I am going to use some part of data. I am going to divide this data set into two parts, training set and test set. So some data I am going to use for training purpose, and some data I am going to use to test our model, that what is the accuracy of my model. So I am going to use its price. And so some part of data set I will convert it in test set to take its price and compare with predicted price, so that I find out the accuracy of my model, and also know the how that whether my model is predicting a good result or not. Okay, so that's why I'm converting it into training set and test set. Okay, so to convert it into training set and test set, you have to use one more module of sklearn.model selection. You have to import from sklearn.model selection, you have to import train test split. Okay, train test split, and let's define one variable, x train comma x test, and y train and y test. Okay, these are variable. So train test split is going to convert it into x train y x test, y train y test form. Okay, so that's why we need 4 variables, and first argument I am going to pass here x, and second one y, and third one is test size equal to 0.2. test size is equal to 0.2. Okay, test size is equal to 0.2, and one more argument we have to pass. Random state is equal to 0, so that we get any invalid result. Okay. Random state. Okay, it's done. So our splitting is done. So let's give if I'm not going to waste time in printing X train, Y train. So everything is done. So let's comment out here training model, and to train model I'm going to use. And one more thing, if you are not familiar, and if you are not familiar, and if you have no idea of machine learning algorithm, then you can check this scikit-learn API, sklearn. You can check this directly from here, sklearn API, and go here in API, and you can check which you have to use. Okay, you can learn every libraries which you have to use. Suppose if I am going to use here random forest. Okay, so just type here random forest. So random forest. Okay, so here as you see that there is two random forest regressor and random forest classifier. So our problem is regression problem. So let's click here random forest regressor. Okay, so this is our class random forest dot ensemble, and on that class you have to use this random forest or regressor class. Okay, from this module. Okay, and this random forest regressor class consists of first argument as an estimator, second argument as criterion, third one max tab. These all are argument of random forest regressor, and these all are some introduction of what is an estimator. An estimator is the number of tree in forest. Criterion, what is criterion? The function to measure high quality of split supported criterion are MSE. So these are default MSE is the criterion. You can use MAE also. So this is a max this is criterion, and this is max tab, this is minimum sample split. So you can learn from this also. Okay, if you are newbie in this, so you can use this also to learn some new stuffs, and to increase some accuracy you can try another part also which is not default. You can try this float. Okay, so by default it's auto. You can try int or float or something like this. So you can use this also to improve your model accuracy. Okay, because sometimes as you see here by default it's 100. Okay, sometimes increasing from 100 to 150 it our model get more accurate result. So you can change this also to make your model more accurate and give a good prediction. Okay, so you can go through this API and check which attribute and which attribute you have to modify so that your model is going to predict a good result. Okay, so what we have to do now, from sklearn dot ensemble, as you see here, as you see in API, from sklearn dot ensemble, what you have to import? You have to import random forest classifier. I am using here random forest regressor. I am using here random forest regressor because I have already checked on which it's going to give a good result. Sometimes generally what we have seen that in supervised learning, random forest is the best machine learning model which is going to give a good result. But sometimes it's not the case, because it depends also on features of it depends also on your data set. Okay, what is your data set, and what's the if your data set is simple, then you can also use linear regression. Sometimes linear regression will work best good, but I'm using here random forest regressor, and you can check later the accuracy of your model, and try some other model also, machine learning algorithm also, to predict to get a good accuracy. Okay, it's on you. It depend on you which machine learning algorithm you are going to select. Okay, You have to just select one machine learning algorithm and test its accuracy, and if its accuracy is good, then you can take it. If it's not, then you can try another machine learning algorithm. Okay, that's how you can check the accuracy of different machine learning algorithm, and at last the algorithm which is going to give a good accuracy will become the best fit model for you, will become best fit algorithm for your model. Okay, so here I am going to use a random forest regressor. Okay, so let's define one variable regression. Regression equal to random forest. We have to provide an instance random forest regressor. So by default an estimator is 100, so I am going to take it as 100. So it's by default, so I am not going to provide anything. So here I am only going to provide random state is equal to 0. Okay, and regression is equal to regression dot fit. Regression dot fit, what we have to do, first argument we have to pass x train, and second argument we have to pass y train. Okay, so what's going to be done now? So this regression dot fit will take x train and y train, and it as I have explained you that it will going to take x train at one side and y train at the other side, and it's going to find out some relation, some correlation by taking some parameters, by taking some coefficient of x features, and it's going to equate these two, and it's going to find out something which is nearly equal, so that like this it's going to predict the result. Okay, it's going to also plot a graph, and it's going to find out which one is the best fit. So like this all the training process is happening. So we have to only provide this algorithm, and this algorithm will do everything. We don't have to do anything, we don't have to compute anything, we just have to provide this code. Okay, so our training is done. Okay, our training is done, and next step is to predict. Okay, so to predict we have to define one variable y predict. Y predict is equal to regression. Now regression object is going to do everything. So regression dot predict, you have to use this dot predict function, and you have to pass x test. This test we have this test set we have taken to test our result. Our training is done, our x train and y train is done, from is used here. Okay, so our training is done. Now I am going to take a x test variable, and I am going to predict a new y variable. Okay, this is our predicted y. Okay, this is predicted by our model. First of all, our model is trained here by using this x train and y train, and now our model is going to predict x test. Okay, so we got our y predict. Okay, so we got our y predict, and now let's comment out with testing result. Testing result. It's not here. Okay, testing result. Okay, so to test result you have to make a list, because I am going to compare my y predict. What is my target? I can simply print here y predict. So let's print here y predict. Print y pred. Okay, let's see. So this is our y predict. Okay, let's print here y test. This is our real value. Okay, this is the real value, and this is predicted value. So our real value is this 14998. This is our real value, and our model is predicting 14337, something close to this 14. Okay, here 23,450, and our real value is 21,000. Okay, So here 28,000 and our model is predicting 27,330. Okay, so our model is predicting nearly equal to this real value. Okay, so we have to compare our training set or test set value with our prediction value. So to frame our this data, you have to use this np.concatenate function. I'm going to concatenate everything. So use np.concatenate function, and in np.concatenate function, so this is our y predict. First argument is y predict dot, we have to do here reshape, y predict dot reshape, y predict dot reshape, and you have to provide here length of y predict, comma 1 is axis. Okay, axis is equal to 1. Okay, and next one is y test dot reshape, length of y test, comma 1. What is this one? I am going to explain you. So this one means it's vertical concatenation, and 0 x is equal to 0 means it's horizontal concatenation. Okay, so I am going to concatenate this with this in vertical manner, so that's why I provided here this, and reshape function is used, so that to bring it into like this, in this form, we have to use this reshape function. Okay, and this is vertical concatenation, that's why I am going to use here also 1, and these two are also concatenated in vertical manner, that's why I have used here 1 again. Okay, so we have concatenated it in vertical manner. Okay, now we have to calculate its accuracy. So let's comment out here with calculating accuracy. Okay, calculating accuracy. So to calculate accuracy, use again sklearn. Sklearn is very important in machine learning. Okay, so from sklearn to calculate accuracy, mean square error, and every other error, and absolute distance, these all you have to use matrix class. sklearn.matrix you have to use. From matrix module will is contain everything, so use here r2 score. Okay, and simply give r2 score, r2 underscore score, and provide here with y test as first argument. All this sklearn.matrix class contain first argument as y test and second argument as y predict. Okay, every time you will use this. If you are going to use here absolute value, then also you have to pass first argument as y test and second argument as y predict. Okay, so you don't have to print it, it's already printed here. So as you see here, we get accuracy of approx 95%. Okay, so our model is predicting a good result. So next what we have to do, we have to make a data frame. Okay, which will contain our real price and predicted price, making a data frame. Okay, so to make a data frame, let's define one variable, my data. My data is equal to, you have to give here as I've already calculated here np.concatenate, so nothing more we have to give here. Simply just because we have to frame our data, so our data is already framed here in predicted and in real form. Okay, so simply define it in a variable my data equal to, Okay, my data is equal to this one. Okay, so our data is defined here. Okay, so here I define my data as this. Okay, so I've already, as I have already converted it into a data frame, so that's why this our first column consists of our predicted value, and second column consists of our test value, that is real value. Okay, so to make a data frame, you don't define one variable. Data frame is equal to, use pandas feature, pd.data frame. Okay, pd.data frame, and pass my data, and second argument you have to pass column to convert it into a table. Okay, so columns you have to pass. Okay, not column. Okay, columns, and first value as predicted value, and second value is as a real value. This done, and print our data frame. Print our data frame. Okay, when you print, you will get predicted value as this and real value as this. Okay, so this is our predicted value 9929. This is our predicted value, and this is our real value. Okay, okay, so our model is done. Okay, as you see here, we get our result. Okay, so this is our code. Importing, first of all, we have imported libraries. This is Numpy, Pandas, and then we have imported our data set, and second one is to define what is our x and what is our y after visualizing our model. Okay, after visualizing our data set, we find our x and y with taking all rows and respected columns. Okay, and then printed x and y to check the result, what is the value of x and what is y, and then we have find out that we have concluded with that machine learning model always accept numerical values, so you have to encode all non-numerical values into numerical form. So that's why I have used label encoding. Why I have used label encoding, why when to use label encoding, when to use one hot encoding. So one hot encoding is used when the variety of features, when the variety of encoded part is less. So like this here, it's only 3 variety: manual, automatic, and semi-automatic. So we have used here one hot encoding, because one hot encoding always convert it into a separate column. So if variety is more, then more columns is generated, and it takes a lot of computation time. And also one hot encoding convert it into a convert this into a separate column, and this column is placed at the first index of, that is 0th index of the x. Okay, so this is about one hot encoding, and this is label encoding. So where feature is more, than on that place we can use label encoding. Okay, so that's how we use label encoding, and this is about one hot encoding. Okay, this is all about, and remainder dot pass through is used to give a one hot encoding instruction that already encoded is also encoded. Okay, try to encode that one also which has been already encoded. Okay, so repetition, to provide a repetition in encoding, we have to pass this remainder is equal to pass through, so that one hot encoding can encode all that values also which is already encoded. Okay, and this is x is equal to ct.fit underscore transform to make x as one hot encoded. Okay, then we have printed x, and as we have seen here, separate column is generated for automatic, manual, and semi-automatic. Okay, next we have used feature scaling. Why we have used feature scaling? Because feature scaling is used to make a to increase, to speed up the training process. Because in training process, at the time of training, we have to plot some data, we have to plot some graph, and we have to identify some correlation between dependent and independent variable. So we have to feature scale, we have to scale our values of feature set in a definite range so that it's easy to train the data set. So that's why we have used here feature scaling. So feature scaling is done, then split the data set in training set and test set. Training set separate, we have separated data set so that some part of data set is used for training purpose and some part of data set is used for testing purpose to test the accuracy of our model. Okay, so like this you can use you can convert it into a training set and test set and then training the model. So to train the model you can use this, and always I recommend you to check the documentation of scikit-learn to know more about machine learning algorithm. Okay, and also to improve the accuracy of your machine learning algorithm, I recommend you to test with different attributes of this class, random forest class, and or any other SVM if you're using SVR, support vector regression, or any other. So I recommend you to test it with using different attributes values. Okay, so that's how I fit or I train the model. Okay, and then I have printed I have stored the predicted value of x test in a separate variable ypred and print the ypred, and I got this. Okay, and this is our y test, this is our real price, and um, this is our predicted price. Okay, now we test the results. So to test the results I store this data into a, first of all I have done here I printed here. Okay, so let's print here to test the result, print my data. Okay, so let's print here to print so this is our my data. So this is our ypred, this is our y real price, y test. Okay, then I have checked its accuracy. This is only to frame the data in a two-dimensional list in which first column consists of y predict and second column consists of y test. Okay, so that's why we have used this step. Okay, x is equal to 1 means we are going to concatenate these two values. This is one value and this is second value. We are going to concatenate these two value in a vertical manner. That's why we have used here 1. Okay, and this is for calculating accuracy. So from scikit-learn.matrix I have imported R2 score, R square score, and R square score we have passed first argument as y test, second argument as y predict, and we got the accuracy of our model as 95%. Then frame I created one data frame using pandas data frame class and pass this two-dimensional list we have already created, and then columns we have to name our column to make it in the form of tables. So to make first column consists of column name as predicted value, second consists of as a column name of real value. So we got our data frame like this: predicted value, real value, and this is our predicted result, this is our real result. Okay, so that's how we got our data. Okay, so our model is predicting approximately 95% result, great result. So this is all about prediction of audit.csv. Okay, so this is our price. So we are successful, 95% successfully predicted our price. Okay, so this is all about this machine learning small project on car prediction. Okay, so you can use this model and the same logic you can use to predict BMW prediction. You can do by using BMW.csv dataset. For practice you can use that dataset, Hyundai dataset. You can use other dataset, and always remember that before going to code, make sure to check your dataset and visualize your dataset and analyze which feature you have to consider, and if your feature consists of NA values and invalid values, then try to encode this, try to convert it into a valid result, and then only you proceed for coding. Okay, and if your values if any feature contain very large amount of invalid value, then I recommend you to discard that feature, because that feature is not going to do anything. Okay, so these all are about machine learning supervised learning problems. So I have already made one video on classification, and this video is on regression. So I think if you have seen the last video and this video, then you will definitely feel confidence in supervised learning problems. Okay, so your concept on in supervised learning, I think will definitely will be cleared, and you feel confidence on dealing with classification and regression problems. Okay, so that's all about machine learning car prediction. This is a regression problem. So if you guys enjoy this video, and if you feel that this video is more interesting and importance, this video is more interesting and it gives you a lot of knowledge and new ideas about machine learning, then please like this video, and if you have any query, then post in the comment box. Okay, and also share to your friends. Okay, thank you guys, thanks a lot for watching this video.